Hello everyone, welcome back to my channel Cloud DevOps Era. In today's video, we are going to discuss about virtual private cloud service provided by AWS. Before jumping into the practical session, let's understand the components under the VPC service. Under VPC service, we have different components like subnets, internet gateway, route tables, NAT gateway, security groups, and elastic IP. Coming to the VPC, VPC stands for Virtual Private Cloud. VPC is like our own private cloud inside the AWS cloud. We can also assume VPC as our own personal data center where we can create subnets, different IP ranges, and control traffic using route tables and security groups. We can create up to 65,536 private IP addresses under this VPC. Coming to the next component under VPC is subnets. Inside VPC, we can create multiple subnets as per our requirement like public subnets and private subnets. Coming to the public subnets, these subnets have internet access through the internet gateway. Coming to the private subnet, we can host backend systems like databases that don't require any internet access. Coming to the next component is internet gateway. This internet gateway allows our VPC to connect to the internet so that our public subnet can able to connect to the internet. Coming to the route tables component, every subnet under VPC should be attached to the route table. This public route table will have a route sending traffic to the internet gateway. Coming to the private route table under the private subnet, this private subnet don't have any internet access as it does not have any public IP. So to install any packages or to install any updates, this needed internet access. In that case, this private subnet should need internet access. So for that, it will send this request to the NAT gateway, which is attached to this public subnet. Coming to this NAT gateway component, this is the crucial component under the VPC. By keeping this NAT gateway inside the public subnet, it allows the private subnet to access the internet through the public subnet. This NAT gateway forwards the request to the internet and returns the response back to the private subnet securely. So while creating this NAT gateway, we required elastic IP address. So the elastic IP address is a static IP address that you can allocate and attach to the resources like EC2 instance or a NAT gateways. So let's dive into the AWS console and create VPC and its components one by one. So I'm switching to my AWS console. So this is my AWS console, and go to search bar and search VPC over here. Click on create VPC, select VPC only, go down and provide VPC name over here. Provide VPC CIDR range. For now, I'm leaving tenancy settings as default. Click on create VPC. Our VPC created successfully. Now let's go to subnets and create subnets over there. Here we can see I'm having two default subnets. Now let's create public and private subnets over here. Click on create subnet. Select VPC over here. Here this is the VPC that we have created just now. Provide subnet name. I have provided public subnet 1A as my subnet name for public instance, and we have to select availability zone. Currently I'm in US East 1A region. In this region we'll be having this availability zones. For now I'm selecting US East 1A as my availability zone. Here we can see this is our VPC CIDR block. Now we have to provide subnet CIDR block over here. Now here we have to create one more subnet for our private instance. I have provided private subnet 1A as my subnet name for private instance. I am selecting US East 1A availability zone. Provide CIDR block over here for our private instance. Now click on create subnet. Here we can see private and public subnets got created. Now go to Internet Gateway. This is my default Internet Gateway. Now let's create a new Internet Gateway over here. Click on create Internet Gateway. Provide Internet Gateway name. Click on create Internet Gateway. You can see our Internet Gateway was created and we have to attach the VPC. Select VPC that we have created earlier. Attach Internet Gateway. Now let's go to route tables. Now here we'll create route tables for our public and private instances. Click on create route table. Provide name. Select VPC. Click on create route table. Now go to subnet associations. Click on edit subnet associations. Select public subnet 1A for our public route table. Click on save associations. Now we can see here public subnet 1A is associated with public route table. Now go to routes. Click on edit routes. For this public subnet we provide internet access, so add route. Provide internet access. Coming to the target for the public instance we need internet access through internet gateway. So select internet gateway over here. Select internet gateway that we have created earlier. Click on save changes. Here we can see we have created public route table and associated this route table to our public subnet. Let's create a new route table for our private subnet. Click on create route table. Select VPC. Click on create route table. Click on subnet associations. Click on edit subnet associations and select private subnet 1A. Click on save associations. Now here we have created private route table and associated private subnet to this route table. So now we have to provide the internet access through the NAT gateway to access private instance. So to access the internet from our private subnet, we have to create the NAT gateway and keep that NAT gateway in our public subnet and install the necessary packages that is required for the private instance. So now let's go to NAT gateway. Click on create NAT gateway. Provide NAT gateway name. Select subnet over here. So we are keeping this NAT gateway in our public subnet 1A. So select public subnet 1A. Through this public subnet, private instance can access internet and install required packages. Here coming to the connectivity type, we have to keep it public over here. If we keep it private, our private instance will not be access the internet. So to provide the internet access for our private subnet, we have to keep it public. So to use the NAT gateway, we required elastic IP over here. Currently, I am having one elastic IP. I have selected this elastic IP. Click on create NAT gateway. Here we can see NAT gateway was created successfully. So now let's go to EC2 service and create public and private instances over there. Click on launch instance. Provide a name to this instance. I am selecting Ubuntu AMI. I am creating a new key pair over here. Keep the default settings as it is. Click on create key pair. Now click on edit. Select your VPC. And since this is the public subnet, we have to select this public subnet 1A. We have to enable auto assign public IP. Coming to the security group, we have to allow 22 for SSH connection and 80 for HTTP. Click on add security group rule. Select HTTP over here. Select from anywhere. Currently I am leaving configuration storage as it is. Click on launch instance. Let's create another instance for our private subnet. Click on launch instance. Provide name. Click on Ubuntu. Select key pair. Click on edit network settings. Select VPC. Select private subnet. As this is private subnet, we have to disable the auto assign public IP. In this security group, we have to allow 22 for SSH connection and 80 for HTTP. Click on add security group role. Click on HTTP. Select anywhere. Now I am leaving configuration storage as it is. Click on launch instance. Go to instances. So now I am going to connect my public VM through my git bash terminal. So copy the public IP. Go to git bash terminal. Provide this command like click on enter. Provide yes over here. Now here we can see I'm in my public EC2 instance. Let's clear the screen. Nginx web server got installed, and let's check the version of the Nginx. Here we can see 1.24.0 as the Nginx version. Access the Nginx application. Here we can see Nginx homepage. So now let's connect to our private instance through our public instance. Now go to public instance. Clear the screen, create a file, paste this content over here, click on escape :W2 to save and exit. Now go to AWS console, copy private IP, go to terminal, provide this command like ssh-i ubuntu @private IP, provide yes. Here we can see here we have connected to the private instance. Let's cross check. Here we can see 10.0.2.10. Here the same IP 10.0.2.10. So let's check the hostname details. Clear the screen and let's try to access the internet. Here we can see we are not able to access internet through our private instance. So to access internet through our private instance, we have to provide a route in our route table. So go to AWS console, go to VPC section, go to route tables, go to private route table. Now select edit routes. We can see here we don't have any internet access route. So click on add route, provide internet access. Now we have to access internet through our NAT gateway, which is located in our public subnet. So select NAT gateway, which we have created earlier. Click on save changes. Here we can see we have updated route to access internet through our NAT gateway. So now go to private terminal. Here we can see we are able to access now. So earlier when we ping google.com, we didn't see any response from the internet. So once we created route, we can see we are able to access internet. So this is all about VPC and its components and accessing internet through our private instance with our NAT gateway. So once you are done with your practical session, make sure you are deleting all the resources that you have created for your practice, or else you will get charged unnecessarily. Thanks for watching.